Welcome back to The Explainer. Today, we are tackling a massive topic: authentication versus authorization. Now, AuthN and AuthZ, they sound incredibly similar, right? They usually sit right next to each other in our code bases, and they both broadly deal with this concept of access. But here's the thing. Confusing these two is arguably the fastest, most direct route to a critical vulnerability in modern applications. So let's unpack exactly why that is.
Here's our roadmap for today's explainer. We'll start with the big mix-up, move right into Gate 1 identity, and then Gate 2 permissions. After that, we'll look at when the gates fail, map out the perfect security flow, and finish up with the developer survival checklist.
All right, Section 1, the big security mix-up.
Look, when these two concepts blur together, we end up building systems where simply logging in somehow grants a user access to absolutely everything. And honestly, this is the direct root cause of massive OWASP top vulnerabilities, like broken access control. It comes down to this. Authentication, or AuthN, asks one very strict question: who are you? Meanwhile, Authorization, or AuthZ, asks, what can you do? Both are absolutely essential, but neither replaces the other. Understanding exactly where one ends and the other begins is literally the foundation of building secure applications.
Moving on to Section 2, Gate 1, identity.
So, authentication is simply the process of proving your identity to a system. The system is essentially asking, are you really who you claim to be? The key word here is identity. It answers exactly one question: is this user who they actually say they are? Now, what's critical to remember here is what AuthN does not do. It does absolutely nothing to establish what resources a user can access or what they're allowed to do. It only establishes identity. And naturally, this is the gate that has to happen first, right? Because you simply can't determine what someone is allowed to do until you know exactly who they are.
And that identity relies on three distinct factors: something you know, something you have, and something you are. While knowledge factors like passwords are obviously highly susceptible to phishing or credential stuffing, requiring physical possession of a hardware key or inherence via biometrics shifts that security boundary significantly. Combining these into multi-factor authentication, or MFA, is for sure our strongest defense against account takeovers. Because think about it, even if an attacker steals a password, they still physically need that secondary factor just to get through that first gate.
Okay, Section 3, Gate 2, permissions.
So once they're through that first gate, Authorization, or AuthZ, answers an entirely different question. Are you actually permitted to access this resource or perform this action? This is exclusively about permissions. Can you read the specific file? Can you modify this exact database record? The really crucial point here is that unlike AuthN, which might just happen once when you log in, AuthZ must be checked continuously on every single request. Just because you are authorized to view your own profile doesn't mean you somehow have the permission to view someone else's profile 5 seconds later. It's granular, it's highly contextual, and it literally never stops checking.
We actually track these permissions using a few different models. You've got your standard RBAC for broad role assignment, like granting admin or viewer rights. But as systems scale up, developers often shift to ABAC for more dynamic, context-aware decisions, like restricting access based on corporate IP addresses or maybe the time of day. For granular resource mapping, we use ACLs to detail exactly which user can read or write a specific file. And for delegated access, we rely on OAuth scopes, which are designed specifically for API communication.
Let's get into Section 4, when the gates fail.
The most common trap here is assuming that a valid session token equals universal access. You'll see these architectures where the only check is, hey, is the user logged in? And once they are, they can just hit any endpoint or view any data. But remember, authentication only proves identity. To use a quick analogy, just because you are an employee of a company, so your identity is proven, that absolutely doesn't mean you are authorized to view everyone else's salary data. Every single resource access needs its own separate authorization check.
Which brings us to a vital security truth. Hiding UI elements is not authorization, it's a UX choice. It is so easy to assume that if you just hide the admin button in the navbar from regular users, those users can't access admin features. But attackers, they bypass the front end entirely. They use tools like Postman or Burp Suite to call your APIs directly. If your backend server isn't validating AuthZ on every request, hiding that button provides absolutely zero real protection.
Let's look at how this leads to a classic insecure direct object reference, or IDOR attack. Watch this microstory unfold. Step 1. A user logs in perfectly fine. Step 2. They navigate to their own profile at API/users/12345. The system checks their session token.
Yep, they're authenticated. Step 3. The user maliciously changes the URL parameter from 12345 to 12346. And here is where it all falls apart in Step 4. The server fails to check ownership. The server knows the user is logged in, but it completely forgets to ask, does this logged-in user actually own resource 12346? Because that auth check was skipped, the attacker successfully steals another user's data. This right here is exactly why broken access control is consistently the #1 vulnerability we see.
So how do we fix it? Section 5. The perfect security flow.
The golden rule of access control is straightforward. Authentication must happen before authorization, period. Because you obviously cannot authorize an unknown entity. But crucially, proving who you are grants 0 permissions by default. Every protected endpoint needs both of these checks happening securely on the server side. Skipping either one is an instant vulnerability.
Let's look at how a secure API request actually flows through both of these gates in the real world. Step 1. A user wants to view their order history, so they log in with their credentials and an authenticator code. That's our AuthN via MFA. Step 2. The server validates this and issues a JWT. Step 3. The user's browser requests the endpoint, attaching that token. Step 4. The server validates the token to confirm the user is still authenticated. And finally, the most important part, Step 5. The server explicitly checks whether this specific authenticated user actually owns that specific order. That's the auth field gate. Only if both checks pass does the data get returned.
In modern application architectures, these two concepts actually map physically to different places. If you're using a microservice architecture, you typically handle authentication at the API gateway on the edge. It validates the token once as you enter the network. But authorization? That happens further in, at each individual microservice. The gateway doesn't know the specific business rules about who owns a specific order. Only the orders microservice knows that. So the edge verifies identity, and the individual service verifies the granular permissions. And what's really brilliant about JWT tokens is that they can conveniently carry both, who you are in one claim and what you're allowed to do in custom claims.
Let's wrap this up with Section 6, Developer Survival Checklist. All right, here are 5 rapid-fire takeaways to secure your architecture. Number 1, enforce strong MFA. Number 2, validate authorization on every single protected endpoint for every request. Seriously, no exceptions. Number 3, never trust client-side checks, validate everything server-side only. Number 4, validate resource ownership, not just broad roles. And lastly, monitor your logs. If you see a sudden spike in 403 forbidden responses, heads up, you are likely under attack.
I want to leave you with a quick quiz to test what we've covered today. An application hides the delete user button from non-admin users. Is this sufficient authorization? If an attacker pulls up their terminal and targets your API directly right now, what actually happens? Think about that for your own apps. Thanks for joining me on this explainer, and keep building securely.